Hello everyone, Jim Dillon here with the Harvester Makerspace. Tonight I'd like to review this 101 Hero 3D printer. It's a sub $100 printer that I bought on eBay. I'm also going to do some simple mods to show you how to make this thing work a lot better than you would think. But first, let's talk about the printer itself. There it is. It already has some of my mods in place, so we're going to talk about those as I get on with the review. But out of the box, it was pretty cool, and I'll show you what the box had in it. It had the printer, the three main pylons, top plate, the bottom plate, and of course the main print head with its control arms. It was very simple to put together. I'm not going to get into some of the trials and tribulations that some of the people talk about in other reviews, but it was simple to put together. Maybe 20 minutes of my time. But what else came in the box? Well, let's see. We got a couple rolls, small rolls of PLA filament, some yellow masking tape that I don't think you're going to want to use, and of course the simple instructions of how to assemble the machine. Honestly, the assembly instructions were a little rough translation, but they worked nonetheless. And here you can get a good idea of the size of the box that it came in. It's a cute little box. That's the size of my hand, so you can get an idea of how small this package is. It came in the mail, no problem. But it's assembled really nice. Now, of course, you can see the wires need a little management. They probably could have thought about wire lengths a little more. All the wires are the same length, so there's nowhere comfortable to put the control module. But the control module does come with a SD card reader attachment, but you can also attach it via USB to your computer. You do need to use Cura to run the machine, but it runs just fine. And actually, once you plug it in, the Cura software will find the Hero or the 101 Hero and actually load the configuration for it right away, which was really nice. It made it easy to work with my computer. And it doesn't come with a printer cable, so you'll have to have one of your standard printer USB cables that you would use. But here are some of the prints that I've got off the machine, and I'll go into those in more depth shortly. But some of the mods that I've done that really made this a very stable machine, I'm very impressed with it actually for $100, is, first of all, I just put some soft feet underneath it so it sits comfortably on the table. It actually does help reduce vibration. Anything you can do to reduce the vibration on this machine and the flexing is helpful, because the frame, without some of the mods I've done, does flex quite a bit. But let me talk about the very first mod I made. The very first mod I made was simply putting rubber bands on the control arms. Now, I used rubber bands with some zip ties because I wanted to assemble the machine as delivered and then do my mods as I wanted to see where the improvements came from. So the first thing I did was I put the rubber bands on the control arms. Now, of course, that did stabilize the head a little bit, so there wasn't as much wobbling. But one thing I found was that this bundle of wires was pulling on the printer head. And so what I did is, some of the holes that were already in the plate, I just strung a long zip tie through there, and I suspend my wires over it. So when the printer is down in the print position, the wire is suspended and not pulling to the side on the printer head. Now, of course, make sure you space your zip ties comfortably away, so when it's in the all the way down position, you're not interfering here. And when it's in the all the way up position, there's a zip tie there, but nothing will ever catch on the suspension zip tie I have there. Another mod I made is I took some sewing machine lubricant oil and I just put a little dab on either side of the bearings so that the travel of the machine was very smooth. That helped a lot as well. But the most important mod I did, and remember, these are all very low cost or no cost as far as I'm concerned. I did have, because I run a makerspace, I had some Lexan laying around, some really thin 16th inch Lexan. It's hard to see because I have some clear Lexan here. But I just cut it to 7 1/4, I believe. I'll have to get the right dimensions and I'll put them in my description. But The 7 1/4 by 6 1/2, I believe, was the height. The reason I went with 7 1/4 was because it's hard to show. I won't be able to show it on video very easily, but there's a groove in behind the pylon feature here. That's why I went with 16th inch Lexan. It snaps right in there. No screws. I didn't have to drill anything into the surface. I didn't have to drill anything into the surface of the printer like some people have, or some people have glued things to this to stabilize it. There's a feature in there with the thin enough material. It doesn't even need to be Lexan. It can be any thin material. Will snap right in there. And again, I'm not sure of the dimension. I'm sorry I didn't write it down before I made the video, but I'll put it in the description below how thick or how wide this piece of Lexan is. Now if you look, I made the Lexan on this side a little higher than on this side simply because I wanted to make sure that the wires could have room to move up and down. But over here, the Lexan is higher. I have it positioned higher up so I have access to get into the machine underneath and get my prints out. And I never use tape when I use PLA. I actually just put glue on the glass. The regular glue stick, Elmer's glue stick, works like a charm. I never have any problems with prints either sticking at the beginning of the print or coming off when everything is done. Now let's get on to some of the nice prints that I've made. Now I'm going to go through these one at a time to show you the progression. So this was the first print. Not the first print, but the first print of this shape that I do. It's one of my calibration shapes that I work with. It's a lofted shape it lofts from a circle to a triangle, and it's got some twist to it. So this was the default Cura settings. The wall thickness was 0.8, I believe, as well as the bottom thickness and things like that. Well, as you can see, because it's such a thin wall, and I didn't put any supports in there, it got real stringy, which is fine. I wanted to see how it would work. So after my first mod of stabilizing the arms, and I changed the default print, I didn't do the arm mod yet. I only changed the default thickness of the printing software, and I made it a 0 thickness on the bottoms and tops so I could make it a hollow print. And here you can see, just by going to a 1.5 millimeter wall thickness, I got some much better results. Now there was some deformation going on the print, but I was pretty pleased with just a simple software change. The next one I did was with the arms. Now the arms, by stabilizing the arms, I was able to get rid of some of that shifting that happens about 3/4 of the way through the print. The next one was stabilized arms and lubricated tracks for the ways, or the servo ways. Now those made a big difference, just lubricating those arms. And the final ones, number 4 here, and its duplicate, were when I put in the Lexan panels, and I got a very, very nice print for less than $100. And with mods that didn't cost me anything, with materials I had laying around. So to verify that it wasn't a fluke, I redid the print here, and it turned out exactly the same. One thing I like about Cura is that you'll see a lot of strings inside of a print like this. I don't mind that because I know that it's picking a different start point for every layer, so I don't get that telltale, like you'll see in other softwares. You'll see the telltale start because there'll be like a line or a deformation on one side or somewhere on your print that shows where it starts each layer, and that gets kind of annoying. Some of my favorite things is, this is my 1 inch by 1/8 inch, I call it my calibration disc. I use this on all my printers, and plus I test infills with it. This was done only after the first mod. This was done after everything was said and done, and it's as good as some of my $500 or $600 printers make. Now, some of the fun stuff I did were these tiny little twisted hexagons. Now, these ones here, I think I twisted a little too much. And because they were so small, they weren't cooling fast enough, so they started to deform. But I was still pretty impressed because I had a really aggressive twist on these. They're only a ½ inch tall and they're really pretty impressive for what it is. So I reduced the twist and I put a small cooling fan to blow across the bed while it was working, and these ones turned out exceptional. I'm very, very pleased with the quality of the prints that come off of this sub $100 printer. Now here's some pyramids I tried to make. They got really deformed at the top, but again, because I wasn't actively cooling the print and it was staying too warm at the top and it was deforming. Now this was an attempt to make a print that I make a lot of. It's an accessory for a Jeep, but here you can see it started to go wonky. But again, these were all done before any major mods were done. I got to reload some new filament into this machine, and I'm going to try to print this again, and I'll follow up with a video on how those turned out. But all in all, for less than $100, I've been very pleased with this cute little machine. Comes in a variety of colors, I guess. Actually, I'm thinking about starting a 3D printer club for kids, and I'll be able to get them in rather inexpensively with a nice little 3D printer. I'll walk them through doing the mods and try to turn another generation onto some 3D printing. So I hope you enjoyed this video. Please give it a like if you do, and let me know in the comments below of any other reviews or mods that you'd like me to see on this machine. Thanks a lot and have a great one.